Okay, welcome back students. So in the previous class we have done the linked list part. Okay, we have completed the linked list part and all the operation of linked list means insertion, deletion. Okay, so in this class we shall start the last topic of this chapter, stack. Okay, but in stack we have to study some topics, some application of stack, how to insert, delete. Okay, let's start. In stack, I already told you stack is what? Stack is LIFO data structure. LIFO data structure. What is LIFO? Means last in, first out. Last in, first out, right? In exams sometimes come, it is very important because why stack is called the LIFO data structure. Then you have to be right. In stack, what is inserted last will become first. Okay, see, so this is a vertical array. Okay, 0 1 2 3 4 5. Then you see, this is an empty stack. Okay, and insertion and deletion happened at the end is called top. Means only one end at where insertion and deletion all will be happen. The end will be called top. In here, when stack is empty, then top will be what? -1. -1 means your top will be blank, means your stack will be blank. In here index will be reversed. Okay, index will be reversed like that, 0 1 2 3 4 5. Okay, you just erase and correct it. Index will be reversed in stack because index will be starting from here, 0 1. The insertion will be what? In here stack is what? Empty, means in here top is equal -1, and in stack insertion process is called pushing. Okay, pushing, and deletion process is called popping. Pushing and popping. Okay, means push and pop. Push and pop. Push mean insert and pop mean delete. Right? When the stack is empty, I already told you the top is -1, but when we inserted suppose 12 in here, 12 is coming here, means now your top will be 0. After that again we insert one element, 13. Now your top will be 1. 14, top will be 2, like that. Top is incremented by inserting element. Understood? Means your top will be incremented, top plus plus when inserts happen. When insertion takes place, your top will be incremented. But suppose this is a case. Suppose this is a case, means you have to insert all the your stack will full. Okay, your stack is complete full. Now you have to insert some value. Suppose 19, you have to be asked to insert 19 element in this stack. How you will insert this? Because your stack is already full. And if you want to enter an element in the full stack, means in that time the overflow concept is coming. Overflow concept is coming. Okay, overflow means your stack is completely full, and after that you have to be asked to enter a element in that stack. Then how you enter an element? Because your stack is already full, then the mechanism coming is called overflow. Okay, because you cannot be able to insert a new element because your stack is completely full. Okay. So now we have to be done the algorithm part for pushing purpose. Okay, pushing means insertion. That is very important for the exam. That's why I first of all clear you the logic. Okay. Pushing in stack array. Okay, you see, I write down the algorithm. This is the just a line, printing line, assuming that array stack can hold maximum n elements. Means we have to be assume the stack will be contain maximum of n element, right? See, first point, if top is equal to -1, okay, top is equal to -1 means your stack is initially empty. Read the item means read the element which you want to insert in the stack. Okay. Third point is, if top is equal to n minus 1, then print overflow. Else top is equal to top plus 1, stack top is equal item n. Okay, you see, what you understood in algorithm. If you understood the basic logic of insertion, then you usually understood this algorithm. Assume, we have to assume array stack can hold maximum n element. Okay, n element means your index is coming from, index is initialized from, so this is a stack, this is a stack. Okay, your index is initialized from 0 to n minus 1 because n element, maximum n element. Okay, n element means your index is initialized from 0, that's why it is ending in n minus 1. Like 50 elements means what? 0 to 49, like that. If 50 is n, this is what? N minus 1. A mathematical concept. Remaining you will see. You see, first point, top is equal -1 means your stack is initially completely empty. Okay, after that you read the item means you read the element. So this is the element 17, you have to be inserted. Okay, then easily inserted it and it will goes incremented, index will be incremented, top will be incremented. Otherwise we have to see all the possible cases. I already told you in algorithm we have to see all the possible cases, right? And if your stack is like that, suppose this is the stack, for this case, this stack, suppose this is a stack, okay? Zero, 1, 2, 3, 4, 5, 11, 12, 13, 14, 15, 16. But this is the stack. Your stack is completely full. Means this line. Top is equal to n minus 1. Means your top is equal what? 5. Means how many elements? 1, 2, 3, 4, 5, 6 elements. If you take 6 as a n, definitely what? Top will be n minus 1. Understood? Means after that you have to ask to insert an element. After that you have to ask to insert the 70 element in here. How you insert it? This will be what? Then condition coming overflow. Else, otherwise what? Otherwise this condition you will be inserted suppose 17, 18, 19. Your top will be incremented. Initially for the case of 17, top will be 0. After inserting 18, top will be 1. After inserting 19, top will be 2. Means top is equal what? Top is equal top plus 1. And in the stack top, item will be inserted. Item will be assigning in stack top. And okay, means what we understood? There is two possible conditions. Okay, one is when stack is completely empty, then you can easily insert it and top will be incremented. Otherwise, if your stack is completely full, you cannot be able to insert a new element, because in that case overflow will be coming. Means you cannot be able to insert a new element, right? And if your stack is suppose like that, some space will be, memory space will be available, and you have to be asked to insert an element, and easily insert it, and top will be incremented. Okay, so this will be the pushing in stack array algorithm. Now we have to be done the programming part for this. Okay, programming part is also very important. Okay, if you understood the algo part, this is very easy, then you easily understood the program part. Okay, let's see. Write a program for pushing an array or array stack, same thing, pushing in stack array. Stack array or stack, same thing. Okay, sometime in exam coming that pushing in stack, same thing. Stack array means stack, same thing. Okay, you write down. They have to be include 3 header file. Function will be declared. Int push, we give the parameter int array, int ampersand int, and next is void display. Display the stack. You have to take variable constant integer 50. Means we have to insert 50 number of element. We assume take as now coming the main function. In main function you see we take the array as a stack under bracket we give the size, item initial top will be initialized by -1 means empty, and wanted variable we use res or any variable you can take, but books write res, that's why I write res. And we take as a character variable y. After you see, we use the while loop. While character is equal to y or this, enter item for insertion. Item for insertion, and item will be given is this variable. After that, we call the function, this push function, this function push stack top item. Stack is given as array top item. If this is -1, cout overflow aborting. Exit. Okay. Otherwise, cout, the stack now is display function will be called stack and top, and okay. First of all, I have to explain this part. You see, for pushing in stack array means we have to insert the element in this stack. We take 3 header file, right? Process is used for the exit function. This function exit. We declare 2 function int push and display, and we take the parameter. One is in array, second one is means a reference, because top is coming in the reference, because top is the index, that's why we take as the reference. Okay, in stack top is what? Top is index, right? Top is not the element, top is the index, means when you inserted the element, your top will be incremented, means the index will be incremented. That's why we take the top as ampersand, means as the reference, right? And item. Okay, after that, you see, we assume a variable constant integer size. Okay, there is something skip, you write down constant integer size 50, constant integer size 50 means this variable. We take maximum number, how many elements we have to insert? Maximum 50 elements, right? And this is item top is equal initially as -1, means we have to assume the stack is initially empty. Okay, and we take as character variable small y. Means while your character is small y capital Y, enter item for insertion, and your item will be inserted in the variable item. This function will be called in the variable res used here, or you can take any variable, but I take res because in books they take this variable. Same thing, this is user defined, you already know. We take the parameters stack, first array, top, index and item integer, right? We take the condition if res is equal to minus 1 means if the stack is what? Res is equal to minus 1, overflow aborting means top is equal to minus 1 means what? Your stack is empty. But res is equal to minus 1 means your stack is completely full. Okay, this is the difference you just remember. When your top is equal to minus 1, then your stack is empty. Okay, but when res is equal to minus 1 means your stack is full. Okay, when your top is equal to minus 1, your stack is empty, but when res is equal to minus 1, your stack is full, means overflow exit. Otherwise the stack is now display stack and display the top. Here we take the top as the directly integer reference. Okay, see, but because after inserting the element, the index is coming as an integer directly. Okay, I show you. After that, after this serially write down, okay, see out backslash n, want to insert more element, yes or no. This is coming in character variable. Now we have to give the function definition. Int push int stack ampersand top and int item. Or here we take int ele element, same thing. If top is equal size minus 1 means your stack is full, return minus 1. Else if stack is not full, your top will be incremented and in your stack top element will be inserted, return 0. Okay, now we give the final definition of next function. Okay, means void display, right? Void display int stack and int top see out stack top. This is a sprinting statement. Okay, endl means end the line. Okay, endl means I have already told you end the line, and we use for display one loop, for loop. Int I is equal to top minus 1, I greater than 0, I minus minus. See out stack I endl. Again end the line and this. See why we use decrement loop? I told you Because in stack you see index is coming where 0, 1, 2, 3, 4, 5. Your index is reverse. Okay. Suppose you have to. In this case, I can tell you, in this case, when stack is empty, your top will be what? -1. Okay. In here, when top is your size -1 means your stack is completely full. You cannot be able to insert a new element. Okay. In that case, overflow will become right. Otherwise, your top will be incremented. I already told you, stack top E element return 0. Okay. In here you see, we use a decrement loop because this here. So this is the element we inserted 12, 13, 14, 15. Okay. Means your top will be what? Top will be now 4. Top will be 4. Okay. Means your I will be 4. We go to this side for insertion. Okay. 0 like that. Okay. Once again, I greater than is equal 0. That's why I saying yes. I greater than equal 0. Because up to 0 it is coming. Okay. That's why we use decrement loop for this. This will be reverse. Okay. Because when we insert it, your top will be incremented. When we see this in like that, from the top position to the bottom, we see the decrement loop. Okay. That's why we use this top -1, I greater than 0, I -1. We use the decrement. So okay, this is enough for this session. In next class, we discuss the popping mechanism, means deletion mechanism. Okay.